Hey everyone, ready for another deep dive? This time we're tackling those giant elliptical galaxies.
Oh,
You know the ones I mean, right?
yeah, those big glowing,
yeah.
yeah, like cosmic footballs, basically.
Exactly. Giant glowing footballs scattered across the universe.
Uh-huh.
It's always been a bit of a head scratcher though.
Yes.
Like how did these massive things even form in the first place?
Right.
But luckily, some new research using the Atacama Large Millimeter submillimeter array. ALMA, that's way easier.
Yeah.
ALMA is giving us some clues.
Yeah.
And the best part, this involves going way back in time to the universe's cosmic noon when stars were basically just popping off like crazy.
It's like, imagine the early universe as this giant construction site.
Okay.
Just stars forming everywhere, like cosmic fireworks going off constantly.
Whoa. That's
It's wild. And ALMA is really special because it lets us see through these like thick clouds of dust and gas, which normally block our view, so we can actually see this insane period of starbirth in action.
That's so cool. So before we get totally lost in all this cosmic dust,
Sure.
can we maybe do a super quick recap of galaxy types?
Of course.
Just to make sure we're all on the same page,
Absolutely. So you've got your spiral galaxies, like our own Milky Way,
Yeah.
with those like gorgeous swirling arms, like
a frisbee.
yeah, cosmic frisbees.
I like it.
And then you've got those elliptical galaxies,
Right.
which are more like, those giant glowing footballs we were talking about.
Yeah. And they're different from spirals, right? Because spirals are still like actively making stars.
Exactly.
But ellipticals are mostly just...
They're mostly just kind of hanging out with their old stars.
Right. And that's like the big mystery here.
Totally.
We know how spiral galaxies form and change over time, but these spheroidal galaxies, spheroidal just means roundish, right?
Yeah, like a ball.
Like a ball. Their origins have been kind of a total enigma.
Yeah.
We just haven't been able to crack it.
Right. But this new research from ALMA might actually change the game.
Oh, really?
They've been looking at over 100 of these incredibly bright galaxies.
Okay.
Called submillimeter bright galaxies, or
SMGs?
SMGs, exactly.
Which easier.
These SMGs existed billions of years ago during that cosmic noon we talked about.
Right.
And they were making stars like you wouldn't believe. But here's the thing.
What?
They weren't actually flat disks like you'd expect.
Wait, so you're saying
Yeah.
these star factories, they weren't shaped like spirals, so what did they look like then?
Well, that's where it gets really interesting.
Okay.
By looking at the light coming from these SMGs, especially in the submillimeter range,
Yeah.
researchers found that the emissions weren't flat.
Oh, wow.
It was more like
Like what?
like a 3D blob.
A blob.
Right.
Hold on. How do you even figure out the shape of something that's billions of light years away?
That's a great question.
We can't exactly fly over there and take a look, can we?
Not yet, at least.
Yeah.
But they use this cool technique called 3D modeling.
3D modeling?
Yeah. Imagine taking tons of snapshots of the galaxy from all these different angles,
Mm-hmm.
and then using a computer to like stitch them all together into this 3D model.
Oh!
Like kind of those 3D puzzles.
I love those.
Yeah. And what they discovered was that the shortest to longest axis ratio of these galaxies was about half.
Mm-hmm.
And that's actually like a key characteristic of spheroidal galaxies.
So instead of flat disks,
Yep.
we've got these compact, roundish blobs just absolutely bursting with stars.
That's it.
This sounds like it could be a pretty big clue for how elliptical galaxies form, right?
It could be huge. Yeah. Yeah, it really seems like this discovery kind of throws a wrench in the old ideas about how elliptical galaxies form.
Oh, yeah. How so?
Well, we used to think they came from mergers of smaller disk-shaped galaxies,
Yeah.
But this new data from ALMA suggests that at least some, maybe even all ellipticals, formed straight from these intense starbursts way back in the early universe.
So you're saying those crazy blobs we were talking about?
Yeah.
The ones just pumping out stars like crazy?
Yeah.
Those could actually be like baby pictures of the giant elliptical galaxies we see today.
Exactly. It's a pretty big change in how we think about galaxies growing up.
That's amazing. But wait a minute.
Yeah.
If those early galaxies were so chaotic and full of star formation,
Mm-hmm.
how'd they eventually become those smooth elliptical shapes we see billions of years later?
That's a good question. It's like going from a wild mosh pit to a perfectly choreographed waltz.
Uh-huh. Yeah.
Well, it's a couple of things working together.
Okay.
First, those intense starbursts use up a lot of the gas that's around.
Right.
which naturally slows down how many new stars can form.
Makes sense.
It's kind of like a bonfire, you know? Eventually it dies down as the wood runs out.
Yeah, I see.
And then as those early galaxies crash into each other.
Oh, right, because the early universe was a lot more crowded back then.
Exactly. So they get bigger, gain more gravity, and everything gets pulled in, smoothing out those rough edges into a more round shape.
So it's like a cosmic recipe.
Okay, I like this.
You start with a bunch of intensely star-forming blobs, let them cook for a few billion years, throw in a few galactic mergers for good measure, and boom! Giant elliptical galaxy.
That's one way to put it. And of course, don't forget about gravity.
Oh, right.
It's the master chef of the cosmos, making sure everything comes together just right.
This is seriously mind-blowing stuff. It makes you wonder what other cosmic assumptions we might need to rethink as we keep exploring the universe.
Right. Like, are there other seemingly settled facts that are just waiting to be flipped on their heads?
Totally. But for now, I think we've done a pretty good job unpacking this particular cosmic mystery.
I think so, too. Yeah. We've explored how those massive elliptical galaxies, which used to be a real puzzle, might have actually started as these intense starbursts way back when. And we've learned how telescopes like ALMA and GWST...
Oh, yeah, and don't forget the upcoming CSST.
Right. How could I forget? These powerful tools are giving us the ability to literally look back in time.
It's crazy.
And see these incredible events happening billions of years ago.
So for everyone listening, the next time you look up at the night sky and see one of those faint, fuzzy elliptical galaxies, remember that you're not just seeing a bunch of stars. You're seeing the leftovers from a cosmic fireworks show that happened billions of years in the past.
And remember that the universe is constantly evolving and changing. What we see today is just a tiny glimpse, a single frame in an epic cosmic movie.
Wow, I love that. Okay, so speaking of peeling back layers, how can we dive even deeper into this mystery? What are the next steps for astronomers trying to prove this theory and uncover the whole story of these elliptical galaxies?
Well, ALMA is definitely going to keep playing a key role observing those dust-shrouded star-forming regions in the early universe. But we've also got some amazing new tools to work with, like the James Webb Space Telescope.
Oh, yeah, JWST. That's the one with those giant gold-plated mirrors, right?
That's the one, with its infrared superpowers.
Superpowers.
Yeah. JWST can basically see through those dusty areas and study the stars and gas inside these early galaxies in way more detail than ever before. It's like having X-ray vision for the universe.
That's incredible. But JWST can't be the only tool in our cosmic toolbox, right?
Oh, definitely not. There's another exciting instrument coming soon, the China Space Station Telescope, or CSST.
CSST.
It's supposed to launch in a few years, and it's designed to survey like a huge chunk of the sky.
Wow.
Capturing images of billions of galaxies across cosmic time.
So we'll have ALMA looking deep into the dusty hearts of individual galaxies, JWST giving us these amazing close-ups, and CSST showing us the big picture of the entire cosmic landscape.
You got it. By combining data from all three of these powerful telescopes, we'll be able to put together a way more complete story of how those early starbursts led to the giant elliptical galaxies we see today.
It's like having a team of cosmic detectives.
Yeah.
Each with their own unique skills, all working together to solve this mind-blowing mystery.
Wow. It really does feel like we're entering this like golden age of galaxy research, you know.
It is pretty incredible when you think about how much our view of elliptical galaxies has changed.
Right. It's wild to think that these like seemingly quiet giants full of old stars were actually once these vibrant, chaotic blobs just bursting with new stars.
Yeah, it's a pretty big change in perspective.
Makes you wonder, like, what other surprises are still out there waiting for us to find them.
Oh, definitely.
But for now, I think we've done a pretty awesome job of explaining this cosmic puzzle.
I agree. We've explored how those massive elliptical galaxies used to be a total mystery.
And now we have a pretty good idea that they probably came from those intense starbursts in the early universe. Plus, we've talked about how these amazing telescopes...
like ALMA, JWST...
and CSST.
Yeah.
Can't forget about that one.
Right. They're giving us these incredible tools to actually see back in time.
It's mind-blowing.
It really is. So for everyone listening, next time you're looking up at the night sky... and you see one of those faint, fuzzy elliptical galaxies, just remember, you're not just looking at a bunch of stars. You're seeing the remnants of a cosmic fireworks show from billions of years ago.
And remember that the universe is constantly changing and evolving. What we see today is just a snapshot in time.
A single frame in an incredible cosmic movie. I love that. Okay, well, with that amazing image in mind, we've reached the end of our deep dive for today. But the exploration doesn't have to stop here. If you want to learn more, there's tons of resources online and in libraries.
You can even check out those original research papers if you're feeling adventurous.
That's right. Keep exploring, keep asking questions, and most importantly, keep looking up at the stars. Until next time, happy stargazing, everyone.